Have you ever wondered how a PLC talks to a flow meter, a variable frequency drive, or a remote I/O module without a custom cable for every connection? The answer is Modbus, the most widely used industrial communication protocol in the world. By the end of this video, you will understand how Modbus works, what a register is, how master-slave polling operates, and why this protocol from 1979 still dominates industrial plants today. Modbus was developed by Modicon in 1979 and placed in the public domain, which is why every instrument manufacturer supports it. It costs nothing to implement, and everyone speaks it. Modbus uses a strict master-slave, or more precisely, client-server architecture. There is exactly one master, typically a PLC, DCS, or SCADA system. There can be up to 247 slaves on a single serial bus, instruments, drives, I/O modules, and meters. The master initiates every transaction. It sends a request to a specific slave address, asking for data or commanding an action. The slave receives the request, processes it, and sends back a response. Slaves never communicate with each other and never transmit without being asked first. This discipline eliminates bus collisions and makes the communication predictable and auditable. Modbus comes in two main variants. Modbus RTU transmits compact binary data over serial cables. RS-485 is the most common physical layer, supporting multiple devices on one 2-wire cable at distances up to 1,200 meters. Modbus ASCII is similar but encodes data as readable text characters, older and slower, rarely used today. Modbus TCP wraps the same message inside a standard TCP IP packet and sends it over an Ethernet network. The register addresses and function codes are identical between RTU and TCP, only the transport changes. Modern plants often use Modbus TCP to integrate field devices into their Ethernet infrastructure without changing the device firmware. Modbus organizes data into 4 tables. Coils are single-bit read-write values. They represent digital outputs like relay states or valve commands. Discrete inputs are single-bit read-only values. Digital inputs like push-button states or limit switch positions. Input registers are 16-bit read-only values, analog inputs like current transmitter readings or temperature measurements. Holding registers are 16-bit read-write values, the most used table, storing set points, configuration parameters, accumulated totals, and analog output commands. Each table has an address space of 65,536 registers. A PLC reading a flow transmitter will typically read 1 or 2 holding registers containing the flow value scaled to engineering units. The function code in a Modbus request tells the slave what operation to perform. Function code 01 reads coils. Function code 02 reads discrete inputs. Function code 03 reads holding registers, the most common request in industrial systems. Function code 04 reads input registers. Function code 05 writes a single coil, turns a digital output on or off. Function code 06 writes a single holding register, changes a set point or parameter. Function code 16 writes multiple holding registers at once, efficient for changing several parameters together. When a slave cannot process a request, it returns an exception response with an error code indicating whether the function is unsupported, the address is out of range, or the value is illegal. A Modbus RTU request has a simple structure. First is the device address, 1 byte identifying which slave to talk to. Address 0 is broadcast. All slaves receive it, but none respond. Then comes the function code, 1 byte specifying the operation. Then the data field, register address and quantity for read requests, or register address and value for write requests. Finally, a 2-byte CRC, cyclic redundancy check, that the slave uses to verify the message arrived without corruption. If the CRC does not match, the slave discards the message silently. The master must time out and retry. A typical read response adds the byte count and the requested register values before the CRC. Quick check. A Modbus master sends function code 03 to slave address 15, starting at holding register 40,001, quantity 2. What is it asking for? Think about it. The answer: it is reading 2 holding registers from slave 15 starting at 40001. Function code 03 always reads holding registers. 2 consecutive 16-bit registers often encode a single 32-bit floating point value. A 16-bit Modbus register holds integer values from 0 to 65535, or signed integers from -32768 to +32767. Process values like flow rates and pressures are usually floating point numbers, so manufacturers store them in 2 consecutive 16-bit registers as an IEEE 750 432-bit float. You must know the byte order, Big Endian or Little Endian, to reassemble the number correctly. A transmitter outputting 12.4 bar might store it as 41460000 in hex across 2 registers. Some devices use integer scaling instead, multiplying the float by 10 or 100 and storing the integer. Always read the device documentation to know the register map, data type, and scaling factor before writing Modbus code. In the field, Modbus failures follow recognizable patterns. A communication timeout usually means the slave address is wrong, the baud rate or parity settings do not match, or the cable termination resistor is missing or in the wrong place. An RS-485 bus with missing termination develops reflections that corrupt data at high baud rates. A slave returning exception code 02 means the register address does not exist in that device. Check the register map. Exception code 04 means the slave detected an internal error. Mixed baud rates on a multi-drop RS-485 bus will cause random failures that are very difficult to diagnose without a protocol analyzer. Always configure all devices on the same bus to identical baud rate, data bits, parity, and stop bits. Here is what most Modbus diagrams do not show. Inside the PLC, a background communication task, the Modbus driver, runs independently of the scan cycle. The driver polls each slave on a configurable interval, stores the responses in a buffer in PLC memory, and the ladder logic reads from that buffer during the scan. This means the value your ladder logic sees could be up to 1 full poll interval old. If you poll a flow transmitter every 2 seconds and the scan reads the value at 1.9 seconds into the interval, the value is almost 2 seconds stale. For fast-changing measurements, set the poll interval short. For slow measurements like temperature, longer intervals reduce bus load without hurting accuracy. Here is what you now know about Modbus. Modbus is a master-slave protocol where one master polls up to 247 slaves. Modbus RTU uses binary serial RS-485. Modbus TCP runs over Ethernet. The 4 data tables are coils, discrete inputs, input registers, and holding registers. Function code 03 reads holding registers, the most common industrial operation. RTU frames contain device address, function code, data, and CRC. Multi-register floats need correct byte order. Common field faults include wrong slave addresses, baud rate mismatches, and missing bus termination. And the PLC Modbus driver polls independently of the scan cycle, so register values have inherent age. Thanks for watching. If this video helped you understand Modbus protocol, please subscribe for more videos on industrial communication, instrumentation, and OT cybersecurity. Every week, we cover topics that matter to instrument technicians, PLC engineers, and OT security professionals in real industrial plants.